Hello, everyone. Good afternoon, good evening, wherever you are. Welcome to this webinar about Cilium in action with real-world use cases. Thank you for showing interest in our webinars. We have about 45 minutes. That means I will quickly start because I have quite a lot of content. A practical thing is to feel free to ask questions in the chat. I'll do my best to answer the questions between some parts of the presentation. I hope you find this useful, and let's get started. So first of all, my name is Raymond de Jong. Hi, I'm based in the Netherlands. I'm field CTO for EMEA region at Isovalent. And today we have a packed agenda talking about introducing a number of use cases with Cilium. I try to explain as much as I can some real use cases with customers and how we adapt Cilium on those platforms, so you have a good understanding how that works in real-world applications. So first, onboarding application secure environments. This is about onboarding applications on Cilium-enabled platforms and to be able to secure them. After which we're going to talk about large-scale application platforms, how Cilium helps deploying huge amounts on huge clusters with a lot of nodes and a lot of workloads and services. A bit about hybrid and multi-cloud deployment. So either on-prem across multiple data centers, or on-prem and in the cloud, or multiple clouds using Cilium. How you can monitor successfully Cilium as data operations, but also golden signals. So being able, without instrumentation and without sidecars, how you can effectively monitor and operate Cilium and your applications running on top of Cilium. And finally, cloud native security at runtime. So as an introduction, obviously Isovalent is the company behind Cilium. Besides contributing to the open source Cilium and eBPF, we also have a Cilium Enterprise release, which is a more hardened, robust Cilium release. And that's a release which our actual customers, most of them actually use. Which follows the open source releases, but has some additional features for enterprises in that product. Obviously, if you don't know eBPF, let's start with introducing eBPF. We use eBPF throughout Cilium to make the Linux kernel programmable in a dynamic and efficient way without changing the kernel. We like to say what JavaScript is to your browser, eBPF is to the kernel. That means that we make the kernel extensible. We can do things based on kernel events which relate to all the solutions Cilium can provide. So what is important to know is that you don't have to be an eBPF expert. All our customers are just operating Cilium, and if in terms of eBPF, we have the expertise and the community has the expertise to support customers with their issues or with any inquiries or specific use cases they may have, which also happens. The 30,000 feet overview of what Cilium can do today, and we're just before KubeCon, so be aware that this will obviously change after KubeCon with some new announcements, but obviously multiple layers. First of all, networking capabilities, observability, and service mesh capabilities. We're going to talk about today a lot on the network policy side, on how you can do, for example, use Hubble as an observability platform to help onboard applications, a bit about service mesh, and obviously about on-prem and cloud deployments with multi-cloud solutions. If we want to talk about our customers and where they are and what use cases they have, it's important to understand the journey. And what we typically see if we look at a customer journey is that most of them start talking to us from stage 2, stage 3. So most of the customers start at some point with deploying Kubernetes, deploying Cilium, and onboarding applications. Once they scale out, obviously zero trust, security, and compliance becomes important. We are moving to production. The clusters grow. The applications are mission critical. That means they need to be secure and they need to be compliant. A lot of our customers are in the compliance area. Think about fintech, financials, government, defense, all that kind of environment. So this is super important. Furthermore, at some point at stage 3, we see customers moving to multi-cloud and also want to be able to connect not only Kubernetes workloads, but also extend Cilium to workloads on the physical network or running on VMs. So we can support that as well. And finally, obviously, enterprise-wide microservices platform is more about role-based access, CI/CD pipelines, advanced automation and auditing and filtering of networking-related events, runtime security, hardened clusters with specific cluster-wide policies to set guardrails for the cluster and to enable teams and application owners to be actually able to self-service using those CI/CD pipelines, etc. More on this later. Let's start with the first use case, and that's a very common one. That's the topic about onboarding applications in secure environments. So think about you have Kubernetes platforms, want to make them ready for production, but you also need to know and be able to onboard applications and secure them. So what are the challenges when we see customers adopting in enterprises applications and also being able to secure them using network policies? It's obviously hard to get started. If you do zero trust and don't allow anything, you will definitely block your application owners. Applications won't work. Connectivity, ingress and egress will not work at all. On the other hand, Kubernetes by default is open, and that's also not ready for production, right? So you want to secure it. And however, you also need to be up to date. While your applications change, maybe there's a new version of your application which introduces a new service. That means that you need to be easily able to adapt your network policies while your applications evolve. And you also want to prevent application teams from simple allowing everything. If you provide self-service capabilities, you definitely don't want them to automatically allow any for egress connectivity. And also, how can, for example, security teams prove that they are compliant and that the policies are enforced, and also be alerted on denied connections, for example. When we talk about this topic, I like to introduce the key types of Kubernetes network risk exposure. This means this is about egress connectivity from your Kubernetes cluster towards the internet, or egress connectivity from your cluster towards resources in your network. Think about, for example, a database or critical workloads on VMs, but also ingress, right? What is allowed to reach your cluster from the internet? Maybe you expose a service through a load balancer, how to secure that, but also the intra-cluster movement, where you want to avoid that workloads can easily hop across clusters within your Kubernetes environment. So the goal is that you want to reduce unused network access, which creates exposure without being required for the application to function properly, right? The goal is you want to have the application running, you want to allow specific connectivity, but reduce any unused or unwanted or unnecessary network access. So we want to also reduce the wide blast radius risk, especially in open Kubernetes environments. When a pod gets exploited, potentially it can be exploited across the whole cluster. So we want to minimize and limit that blast radius as well. So when we work with our customers in the field on this topic, we try to get started with a so-called per namespace coarse-grained network policy, while also have, for example, the platform team creating guardrail policies using cluster-wide Cilium network policies. What that means is that you create a baseline policy or a set of policies, which obviously allows specific things you need to have for the cluster to run. Think about monitoring like Prometheus, think about DNS, or think about centralized services you need to expose for applications to work properly on your cluster. Then on a namespace level, you can start with a per namespace policy, maybe using automation to draft and automate the deployment of namespaces, and a default policy for a given namespace, which allows traffic within a namespace, but not necessarily out of the box ingress and egress. That can be specifically being exposed through a load balancer with an ingress network policy, or for example, using egress connectivity, we see also the use of egress gateway for having specific outbound connectivity, but also egress policies. And then use, for example, Hubble, and I will show a bit later how that works as well, to provide visibility in the actual communication outbound and inbound. So you make an informed choice how to secure workloads in your namespace for both ingress and egress connectivity. And the goal is that with that information, you can transition from a coarse to fine-grained policy. And this can be done through the platform team. This can be done in combination with the application team, or if the application team themselves are ready to create network policies with tools such as the network policy editor, they can use, for example, CI/CD pipeline to make it more fine-grained. And then you can, as a platform, you can prioritize namespaces based on the most secure, sensitive applications, but also measurement of exposure versus use connectivity. So what you actually open and allow, and also monitor if that connectivity is actually being used, or that you see connectivity not at all being used, which is a confirmation that you can secure that specific ingress point, for example, or that service you have exposed. You can also transition for egress, so access to all your networks. You can start with only allowing specific FQDNs using Cilium network policies, or smaller CIDRs with a port, and obviously access to specific FQDNs on the internet, or if you don't have that capability or don't have that information, using small CIDRs. I mentioned FQDNs quite a lot. That's definitely something Cilium can help with, and what customers are using a lot as well. Because, for example, in the example of one of our media companies we work with, they run media content in S3 buckets in the cloud. That means that the IP addresses associated with those buckets change all the time, and therefore it's for them not possible to create network policies based on CIDRs, because they need to know basically a whole AWS CIDR set being used for S3 storage. So instead, they secure it using FQDN rules to only allow access to a specific FQDN. And then when you make that move, you will be able to expose, for example, through a service type load balance or ingress or gateway API using the new service mesh capabilities on specific layer 7 paths, only access inbound on a given service, but also outbound can safely and secure very specific on FQDN or IP address with a specific port. So you want to make security decisions based on your data you see using Hubble, and we highly recommend, and that's what all our enterprise customers do as well, is use the Hubble UI with self-service, using role-based access for tenants, so they can manage their own namespace, and they can have a tool to make network policies, create network policies based on the network flows they see. Now, Hubble obviously is our observability platform, and for people who don't know Hubble yet, we provide a UI which shows the service dependency maps, but you can also use the CLI for a detailed troubleshooting and following of flows, or even being able to output that and import it in, for example, other security tools. And another important tool I want to mention is our integration with Grafana using Hubble metrics, where we can also expose policy-related metrics, for example, to Grafana dashboards, which gives you confirmation that you actually have matching traffic based on the network policies you create. And also you can monitor drops, right? So if for example, a policy drops traffic, these Hubble metrics show that to you with a Grafana dashboard. This is the service map I mentioned before. So this allows you on a namespace level to learn how the connectivity between services in a namespace is, but also in case of connectivity from other namespaces, or for example, external resources either on your network or in the cloud, you will also be able to see that and make security decisions based off of the traffic if you want to allow, or you may need to secure it more specific. This is different, obviously, on our identity-based security model, where we are not interested in tracking IPs, but instead interested in tracking IDs or identities, which are based on the workloads you deploy and based on the unique set of metadata each deployment has. So, for example, a front end has a specific label, tier equals front end. A backend deployment has a tier equals backend label. That's by itself is a unique set of labels, which is used throughout the cluster, used by Cilium to secure workloads using network policies, but also to show in Hubble UI the flows between services as such. I mentioned before also layer 7, and that's driven through HTTP, for example, visibility. So also using Hubble, what we see is that our customers learn how the application is actually using API calls or gRPC calls, and they want to specifically only allow specific methods on specific URIs. So between services, you can really super secure service-to-service connectivity is based on specific API calls instead of just allowing on layer 4 access to a given service. And this is what I mentioned before. DNS-aware Cilium network policies allows you to securely access specific to FQDNs based on their name, based on wildcard or regex-based policies, where you allow only access to specific FQDNs. And then as a platform team, you can also maintain guardrails in terms of cluster-wide network policies. So as a platform owner or as a platform team, you can secure the cluster and only allow on a namespace level specific exceptions. And what we see in practice is that most of our customers use some kind of automation with CI/CD tool or with Argo or Flux, and definitely on GitHub or GitLab-based platforms where they, for example, use automation to check automatically if there are matches for example, PRs on a network policy, which has a source or destination, which is absolutely not to be allowed. So, for example, one of our customers has specific set of IPs they have secured, and they don't want to allow automatically based on network policy PRs created by application teams. So you can leverage those kind of automation to enable self-service, but also automatically avoid teams for adding network policies which has some kind of destination you don't want to allow. So this is a quote from one of our customers from Palantir. They are very successful using Hubble UI to understand network flows and to be able to secure their workloads, and also using automation to manage that successfully. I have a question in the chat from Advait. I hope I pronounced that name well. I want to get started with contributing to Cilium projects. I'm a student new to Cilium. Okay, can you please help me out with further guide on what I should do next? Yes, are there some interesting beginner-friendly projects that I can take up? Absolutely, yes. So thank you so much if you want to contribute. Happy to help you as well. There are definitely great issues, they call them. I think they are labeled with great first issues in our GitHub repo, which allows you to easily get started with contributing to Cilium. So have a look there and also join the community. I know our engineering team is happy to point you to maybe an issue you are interested to work on. So the next use case is about large-scale application deployment and how Cilium makes it possible to achieve such a large scale. This is about, for example, sidecar-free service mesh to avoid redundancy, to avoid unnecessary resources being eaten up through sidecars, instead using eBPF where we can as much as possible to allow better performance in your clusters. Also reducing data overhead and operation and complexity by avoiding sidecars. Also high performance load balancing. For example, you're able to achieve high throughput, high performance load balancing through Cilium using features such as XDP or maglev to allow the best performance based load balancing. Also standalone. We have an excellent blog at our Cilium website where a Czech operator talks about using Cilium in standalone Linux boxes for high throughput, high performance layer 4 load balancing. And also scale. Cilium is designed for real scale. That's also the reason why clouds adopt Cilium as the default CNI, because with Cilium we are able to support clusters beyond hundreds and thousands of nodes and tens of thousands of services. So for example, Datadog is a very avid open source Cilium user, which has scales with thousands of nodes, huge amount of services and network policies, and they run Cilium successfully for their Datadog platform in open source as well. So that's all based obviously on eBPF. This allows us to create this huge scale across multiple clouds and also support IPv6. We do have customers running IPv6 to be able to overcome IP constraints and to be able to be flexible in assigning IP addresses across multiple clouds. Also think about, for example, telcos. So telecom technology using SRv6 for high performance routing using IP and IP, so layer 3 VPN with IPv6 as well. And at the core of this is our kubeproxy replacement, which is based on eBPF, which basically replaces legacy technology such as IP tables, and instead makes a high-performant east-west load balancing solution based on eBPF, which is per CPU hash table based, instead of using a kubeproxy based on IP tables, which is a linear list. And in practice, what we see beyond 50 nodes, so 50 nodes, 40 approximately, depending on how dense your clusters are, we see lagging of applying, for example, network policies, or you see a delay in when you scale out an application that a service is actually able to reach out to endpoints which are new deployed. So, and that's all because of legacy kubeproxy IP tables based implementations are not a real fit for the high churn and the high density of Kubernetes clusters at scale. So beyond 40, 50 nodes, we can see a delay of even minutes, and in some cases, even 5 to 10 minutes for actually IP tables being updated. And using eBPF, we create per CPU hash tables where each change is an atomic change and instantly updated when, for example, a deployment is being scaled out and the service can successfully load balance to that new endpoint. And that's the reason why the clouds are standardizing with Cilium. Google Cloud, Data Plane v2, Antos under the hood is actually Cilium. Alibaba runs Cilium. Azure has announced that for last year, they are transitioning all their AKS clusters to use Cilium by default, because they also recognized and seen that customer will run into issues beyond a certain amount of nodes, and Cilium solves that problem. And AWS, so EKS Anywhere, has by default Cilium, and hopefully we have some good announcements that could come as well about AWS and Cilium partnership there. To quickly introduce Azure CNI powered by Cilium. So this is the Microsoft Azure solution where they now use Cilium as the default CNI powered with the eBPF to have basic connectivity either in overlay or VNet mode, integrating with the Azure IPAN, but also the ability to effectively have load balancing at scale and the ability to apply network policies at scale powered by Cilium. And then service mesh. Obviously, if you run at scale, you want to monitor, be able to run workloads and monitor workloads at such amount of scale, being able to have successful connectivity, be able to use ingress or gateway API resources to connect to your workloads. And using Cilium Service Mesh, we avoid the sidecar problem. So we have a service mesh implementation based on a proxy per node instead on a sidecar per service or pod. Instead, that will save you a lot of resources in your environment. And we already see customers moving, for example, their F5 load balancer implementations to, for example, ingress resources powered by Cilium, because they can, first of all, make it more cloud native, so they can manage that connectivity, and also avoid the cost of maintaining, for example, a set of F5s for simple load balancing solutions you want to use in your Kubernetes clusters. Using Cilium Service Mesh, we reduce resource usage. So we allow customers to be able to better use their clusters for actual workloads instead of being constrained by the amount of resources a given service mesh solution will use. And we also avoid the latency between an app and a service mesh proxy and the connectivity to the physical network by using eBPF, where we shortcut the connectivity directly from a pod on a layer 4 level, for example, directly to the network interface. And in case if we need to do, for example, layer 7 observability or golden signals, we use the Cilium agent with the embedded Envoy proxy to process that specific request. And then we give it back to eBPF to allow that connectivity resume on the physical network. And we've seen a huge difference in terms of performance comparing to traditional sidecar-based implementations. Also consider the amount of time at scale, and that's something also we've seen at our customers, the amount of time it saves for endpoints being ready and endpoints to be actually being connected to. Because on the node, the Cilium proxy is already ready to serve those connections. What we see is that, for example, there are, for example, IKEA is a reference customer in Europe. They are using Ingress today already for replacing layer 7 load balancing solutions they formerly did on external load balancers and or a combination with HE proxy, instead with a Cilium-based Ingress load balancing solution with standard Kubernetes Ingress resources, where Cilium is the Ingress class. We also, in the banking space, have support for Kubernetes services with annotation. So think about gRPC load balancing on simple services, where we can do, for example, apply specific load balancing algorithms, for example, least request or round robin for gRPC calls across clusters. Gateway API is fairly new, but that's definitely the future solution, or the Ingress version 2, which has a lot more features and allows you to have a separation of a platform team configuring the gateway class and the gateway resources, where an application team will configure HTTP routes to be bound to a specific gateway. So that provides more multi-tenancy capabilities. I'll pause a moment here. Is there any new question? No. Then I want to move on to another very common use case, is the use case of hybrid and multi-cloud deployments. And there is a question in the meantime: can we create node-to-node encryption using Cilium? We have encryption pod to pod using Cilium. That means that endpoints are having encryption. Node-to-node encryption is actually on the roadmap and soon to be released. So also that is coming soon. And it depends a bit in which context you ask this. If this is in a service mesh context, we do use IP, and that's something our customers use a lot, either IPsec or WireGuard for end-to-end encryption in transit, for pod-to-pod encryption. If you look at authentication, if you have with service mesh a specific authentication use case, we are going to support soon MTLS with, for example, SPIFFE integration. So you can also authenticate a given workload before actually allowing connectivity to be started. So I want to start with a quote from Adelina Simeon. She's a technology evangelist from Form3. Form3 is also in the fintech space, a customer we work with, and they needed a networking solution for their multi-cloud architecture. And they have run on different cloud providers and on-prem. So using Cilium, we are able to help them supporting network policies at different layers and also be able to monitor and deploy it anywhere they need. To introduce cluster mesh is independent of running workloads on-prem or in the cloud or in the edge for example, telco use cases, allows you to connect multiple Cilium clusters together, independent if they are in the Google Cloud or on OpenShift on-prem, and to be able to use all those services we have with Cilium, such as service mesh, load balancing, service discovery, the ability to use Cilium network policies to secure workloads across clusters based on their identities and observe their traffic. So you can also see between clusters where the source and destination traffic is coming and going to, and also obviously connectivity in terms of routing and networking, including encryption, for example, using WireGuard and IPsec. How it works is we used, again, the identity-aware concept. That means that each cluster has their own set of resources with their own set of identities. And each cluster has read-only access to learn each cluster's identity it connects with. And we use those identities across clusters, obviously, to secure them. So for example, if you have a network policy across clusters, Cilium understands which cluster this identity is originating from, and for example, which cluster this source identity wants to connect to as a destination identity. So we have end-to-end connectivity, observability, and security between clouds. And then you can do multiple things. So for example, Form3 and most of our other customers use high availability features for cluster mesh to be able to have services across clusters with endpoints across clusters, which allows them to have high availability and connectivity across clusters. Meaning that when backends fail, so all backends for some reason in a given cluster fail, we are able to fail over traffic to the remaining cluster. Another very common one is more in the service provider or managed services space, where you may have a centralized shared services cluster where you provide services for your tenants. And each given tenant, for example, has a dedicated cluster with their own resources, but they need connectivity to this shared service. And this is an example, for example, with a Vault service, which centrally stores credentials or secrets. You can expose such a service to be connected to from different tenant clusters. So this avoids, for example, that each shared service needs to be deployed in each given tenant cluster. So you can centralize it and easily allow access to that centralized service cluster. Another use case is more in the edge telco space, is where you, for example, have edge clusters and you want to keep those edge clusters small and you don't want to maintain stateful data in those clusters. Instead, you want to collect, for example, metrics or throughput usage statistics and forward those to a centralized service, which actually runs in a stateful cluster to gather that data and to store it and to do something meaningful with that. So this allows you to keep your stateless edge clusters as small and nimble as possible, also being able to easily be life-cycled, whereas the stateful cluster is more a centralized cluster where you centralize connectivity to a given data store service in this example. Another important feature here is the local service affinity, which allows you, especially across clouds, to prefer local endpoints instead of remote. That keeps traffic within a cluster in each cloud, in each VPC, and only fails over when all backends in a given cluster fail. So this will avoid cost for throughput between your clouds and also latency, because if you have a VPN across clouds, you will obviously have some latency you want to avoid for normal communications. Another use case is the remote service affinity, where you can temporarily tag this global service to prefer remote endpoints instead. This allows you to, for example, do maintenance on backends in a given cluster and temporarily forward all traffic to a given backend service in the remaining, or in cluster 2 in this example. And when you're done with maintenance, you can remove this annotation again. It's a simple annotation on a simple service to have traffic again, for example, local or by default across clusters. And then finally, the network policies allows you to secure traffic between clusters. So maybe for specific workloads, you only want to allow, for example, cluster 1 to reach services in cluster 2, but not the other way around, depending on your applications or use cases. And using Cilium network policies, you can secure traffic across clusters. I'll pause a minute here. Are there any questions related for this use case? How does Cilium cluster mesh differ from service mesh? Not that much. There are a lot of capabilities we use in cluster mesh, such as routing traffic between services across clusters, which you normally would do with, for example, an Istio-based service mesh. So I don't have these slides included in this specific session, but you can actually mix and match Cilium service mesh with cluster mesh to have the service mesh capabilities across clusters. And for example, the ability to load balance across services across clusters is done through a simple annotation on a plain service of type cluster IP using Cilium cluster mesh. So it's very easy to use, no sidecars involved, and the ability to secure those workloads without implementing a service mesh solution. So if you, in other words, if you consider, for example, multi-clouds, if you have a use case for multi-cloud networking, you want availability across clouds, you can do that with Cilium without actually using any service mesh capability based on Istio, for example. I hope that answers the question. Another very common problem for running workloads in production is the ability to monitor for golden signals. A challenge we see with our customers a lot is obviously at scale with production ready applications, you need to be able to successfully monitor it, right? So we have an observability challenge we are able to solve with Cilium and Grafana integration. One of the challenges is obviously that the connectivity is layered, right? So you have an application layer, session layer, transport layer, network layer. There can be different problems in different layers, and each layer hides problems above or below the layer for the layer below that layer. So traditional network problems will most likely appear in the data link, network, or transport layer. Well, for example, application-specific issues, perhaps API issues, will be seen in the application layer. Another big problem at scale, especially in cloud, is the signal to noise problem. You run huge clusters, maybe across clouds. That means that you're looking at different tools and different user interfaces on a given cloud to follow workloads. And you're only looking at IPs and using Cilium instead, you can watch for identities because we understand the workloads being run. And then the mess of IP addresses becomes much clearer because you're not looking at IP to IP, but from service to service identities. So we have context of the actual workload running, independent on which node or which cluster it runs. Obviously, when you look at on-prem, for example, network monitoring devices, think like Splunk or SIEM or firewall solutions, they have constraints in terms of throughput, but also in capabilities of monitoring. They also don't have context of the application. They only see source IPs. The cloud provider network flow logs is something I just explained. You know, you're looking at perhaps at an Amazon dashboard with source IPs from node to node, but you are not able to understand actual application context. On the operating system, you also don't have context of your workloads. So maybe you want to modify application code to provide added capabilities for monitoring, but that obviously is hard to maintain. And it's actually one of the reasons why Service Mesh has evolved as it is as today, because Service Mesh can also provide a lot of visibility from service to service connectivity, but traditional Service Mesh have obviously one downside, and that's the additional overhead it provides. So using Cilium and Grafana removes that complexity and overhead. This is again driven on identity-aware networking, API-aware observability with eBPF and Cilium, where we use eBPF to get metrics out of the workloads and to be able to export those metrics to, for example, Grafana using Prometheus. But you can also use Datadog or other tools to get information and to create dashboards which show some kind of either data operation or golden signals you want to use for monitoring the applications. Grafana has invested in our company, and we have introduced partnership with Grafana as well. So especially from KubeCon onwards, you will see some new announcements and enhancements being done in Cilium to be more effectively integrated with, for example, Mimir, Loki, and Tempo in terms of integrating capabilities such as metrics, logs, or traces, using those tools for you to monitor your applications. So if you think about golden signals, you can already use Cilium and Grafana to monitor, for example, HTTP golden signals, things like request rates, latency, response codes. You don't have to use any sidecar implementation. You don't have to enable Cilium Service Mesh as well. This is actually based on plain Hubble, Cilium Hubble-based metrics, which are based on HTTP metrics. The only thing you need to apply is a simple layer 7 network policy, which will trigger these metrics to be exposed and to be used in Grafana to show, for example, return codes or duration or errors as such. So also no instrumentation of the application. Also, Cilium out of the box provides layer 3, layer 4 networking monitoring capabilities. So first of all, the Cilium agents themselves can already be monitored. Things on throughput, latency can be detected. Also, SYN-ACK mismatches or ICMP timeouts, but also retransmissions or increased round trip times, which may indicate some kind of network layer latency. And if you have instrumentation for your application, you can also use traces, exemplars in Grafana to see specifically information you can query with Tempo to see, for example, for a trace, to see what specifically went wrong, what the return codes were and others. So in practice, what we'll do with our customers and how I see them being deployed, it really depends on what you try to achieve. Obviously, if you enable all the metrics, you will have a bit more overhead in terms of gathering all those metrics and gathering data for monitoring the applications. That means that it really depends if you only want to see, for example, flows, drops, verdicts based on network policy. You want to only enable a specific set of metrics compared to, for example, monitoring layer 7 performance of your applications throughout your cluster. So we can help you definitely with starting with the right set of Hubble metrics in your Cilium config to get started based on the use case you may have for monitoring. I'll pause a minute here to see if there are any questions on the golden signals part. Okay. And finally, given the time, I quickly finished today's session with cloud native security at runtime. This is obviously a very common question, not only networking security, but also runtime security. And we're working with some specific customers on specific runtime monitoring use cases. Think about trading, high performance trading platforms where, for example, you want to monitor multicast UDP traffic or want to monitor transactions as such. So beyond the networking layer, also see on the process layer using eBPF if something is allowed or compliant based on the policies you will set and based on the alerts you need to be triggered if something is not in compliance or not a transaction, which is, for example, not to be allowed. And this is based on Tetragon. This is our runtime new open source project we introduced in Cilium last year. eBPF based again. So instead of all kernel related events on networking, we're looking at process runtime related events in the kernel where we can hook eBPF programs on using Tetragon without modifications on your application. And this also provides contextual information about your Kubernetes objects and prevents access to resources or prevents file access or process being started using Tetragon. So quick overview of what it can do. And depending on what you need, if you, for example, want to monitor file access, you can create specific tracing policies which monitor specific files not to be overwritten. So maybe you want to secure only read access to a given file, and once a process tries to write it, we can kill the process immediately. Also think about escalations of privileges, namespace escapes, access to data, access to storage devices or functions, scripts, code execution, etc., etc. Tetragon, based on the tracing policies you need, can secure those events and also report the data and metrics to, again, things like Prometheus, Grafana, but also Elasticsearch and SIEM platforms such as Splunk. So also in the compliancy space, we see a lot of interest in this. And compared to, for example, other runtime solutions using eBPF, Tetragon is synchronously, which means that without interaction with any policy engine, we actually immediately can detect an exploit or process being started, which is not allowed, and then kill that process without waiting for a, for example, confirmation of a policy agent, if that specific pattern is actually allowed or not. So super powerful. And we're working daily with our customers on specific use cases in terms of compliance and security for their critical applications. I hope you got something out of this. Feel free to ask some more questions. But before I want to finish off the webinar, obviously I want to point you to some good resources where you can learn more. All of these features can be tested by yourself using isovalent.com labs. We have instruct-based labs where you can just use your browser to go through, for example, a specific guided lab about encryption or, for example, Tetragon runtime security. So you can learn more about our feature and our products, and also being able to, for example, earn a badge on some specific labs where you completed that specific lab and was able to successfully answer the questions. All our documentation is obviously on cilium.io and ebpf.io. We have a community Slack channel on cilium.slack.com where you can ask all the questions, and you'll see community members, open source users, and our engineering team happy to respond and help you with any Cilium, Hubble, or eBPF related question. I'll wait for some additional questions. If you didn't have any questions, please let us know what you think. And I hope you enjoyed it. And thanks for joining this webinar. And I wish you all a very good day. Actually see some Q&A in the questions. can you throw some light on Excel BPF and where and how to use it? Well, actually, that was a first April's fool's joke, I think it's called. So there is no such thing as Excel BPF as such. But the fun fact is that using eBPF, you can do a lot of things, even things related to calculations as such. But we're not planning to introduce any kind of such technology. There's also a question related to higher remote work opportunities for students. Absolutely, we do. You can contact, for example, myself, and I can see where we have possibilities. I do know we did have some kind of summer school kind of program where some people from our engineering team worked with a select group of students. And obviously on the isovalent.com/careers website, you can see all current open positions. So feel free to reach out to us there as well. Okay, if there aren't any other questions, I think we can stop sharing and we can close the webinar. So again, thanks for your time. Have a great day and hope to see you at KubeCon. If you're there, please meet us at at our booth on KubeCon, and we're happy to demo or to discuss further or answer any questions you may have there as well. So have a great day. Bye-bye.